JCON. I hope you have enjoyed the conference so far. I just heard from the organizers that there has been almost 3,000 people already online in the presentation. So I think that's a pretty nice result, actually. My presentation will be about devices and web applications, and basically that how you can access devices from web applications, because web is actually not by standard that easy to access the devices, unlike operating systems. My name is Tahvonen. I work at Vaadin. At Vaadin, we make web applications, and I work in our marketing department these days. I have used to work on the R&D side for quite a long time, and once in a while, I have been also helping our service sides, where we have been delivering some web applications for customers. And I could not say that I have a hobby called developing, but I do quite a lot of R&D or development for my hobbies. So I'm pretty active member on our local orienteering club, and orienteering is an enduro sports that we do quite a lot in the Nordic countries, where we run in the forest with map and try to navigate to different things. And a lot of that involves IT and also devices for tracking and time taking and so on. And I'm also pretty active hunter, and I have also built some systems for our hunting club. And in these hobby projects, I often also use devices. And in this presentation, I will share my experience, how device integration can be done for web applications. And I will also talk about emerging technologies that are available today for Chrome that you can actually use to implement a connection to your custom device directly from the browser. In the beginning, I will be talking about these historical solutions that are some of them are still valid, some not, some are completely broken already. But then the last method is these new APIs, and that is WebBluetooth, WebUSB, and WebSerial. So those are new things in Chrome, and hopefully in the future for some other browsers as well. And in the end, I will show hands-on example using this new WebBluetooth technology. And in that example, I'm taking in data from this kind of device that is a heart belt monitor. And using that, I can analyze my heart rate. And because this is high-tech from Finland, this is the best heart rate belt that you can get actually on the market. It can actually deliver even the millivolt samples from my chest. So using that, I can actually plot the ECG curve automatically on the web application as well. So let's get going. So what's really the issue with the web and devices? That's because web is actually, it's not designed to be an application platform. Unlike operating system is solely designed for applications to consume different devices and hardware that the computer has. So web was designed for hypertext originally, and then somehow it happened that it became the most popular application platform for the future as well. And also in browser, because that's a network thing, there must be extra concern for security and so on. We are using quite a lot of these devices actually in each and every web application and in all applications, but we are using them through very strong abstractions. We are using display and speaker to display some data, and we are using some HTML elements to get input from the user, but we are not directly using keyboard or microphone, but we are using these elements and some JavaScript APIs to get the data from these standard devices. But the difficulty actually comes when you actually have some kind of a custom device, like this heart rate belt, that each and every browser just cannot provide an API for. And also, sometimes the standard devices, like printer, there is a method called print, which I actually had in the previous slide, window.print. You can call that kind of a JavaScript API from basically any event handler, and it will open the hardware dialog. But in some business applications, you need to print a lot, and you just cannot always interrupt the user when something needs to be printed with an operating system dialog that is asking it how many copies you want. Do you want it in black and white or color and so on? But you want to just automatically get the data to the printer and get it out. And that's also like a device integration. You need to go through the abstraction provided by the browser and use the device directly. Yeah, and until recently, until these new APIs, there was basically no ways to access these custom devices. Everything had to go through the abstractions, but we had, of course, some hacks that we used. And number one hack that is not that often used, but I think this is the best of the best integration for web applications, and also actually for normal applications. So some devices are inputting data. For example, in the screenshot, you can see this device to scan barcodes. They are basically inputting data. If I scan my invoice that has this kind of a barcode system in Finland, that contains basically a lot of numbers. It contains the account number, the reference number, the amount of the invoice, and the due date. And that's just basically numbers. And if this scanner tells to the operating system that I'm a keyboard, then in the web application, we can just show one input dialog or input field. And when the user focuses that, or we can focus it automatically when this dialog is opened, you can just use the scanner, scan the barcode, and then you will have automatically filled in invoice details in your banking application. That's very handy. You don't need to install any drivers. You just plug in the so-called keyboard, and then it's there. These barcode scanners, they actually quite often, like most of them, has this like a keyboard emulation available. But some of those, they have a custom mode where you can then get to the lower level as well. But then you need some kind of a driver installed. So yeah, if you have a device, or if you're planning to implement some kind of a device, consider if you can make it look like a keyboard or mouse. Another thing is custom browser plugins. And this actually used to be one of the best ways to implement device integration, because the custom browser plugins, those browser plugins that were originated from this original Netscape plugin API, they were pretty powerful, and they were able to do pretty much the same things as normal applications. And in the screenshot, I have here image of old Garmin wrist computer. That was actually very high tech at that time. It was a huge device. It almost filled my whole wrist, but it contained GPS chip, and it also connected to this kind of heart rate belts. And the data could be collected to browser applications using their so-called Garmin Communicator browser plugin. So when you connected this USB device and the watch to the computer, if you had a web application that could use JavaScript to access all the files that were in the wristwatch, and this was very nice system for my previous, or actually I still maintain that application, but this feature doesn't work there. But I'm having this kind of a training diary for endurance athletes, and this was the snappiest way at that time to fill in the training details for your diary. So you automatically got the time of the training, the duration, heart rate, and so on. But yeah, these plugins, they are no more allowed in the modern browsers. And yeah, one comment about this still, actually, it didn't always need to be a custom browser plugin. It could have been also, for example, Java applet. So Java applet was implemented using browser plugin as well. And if you had a signed Java applet, you could access, for example, the USB bus, and then you could implement your own thing. But this is history. This handy thing doesn't exist anymore. So we have needed to go forward. And network connected device, this has become probably the most common thing. So chips for Wi-Fi or 4G connection, they don't cost almost anything these days. I have a couple of examples here. The TK201 device, this was actually used in one of our example applications that we built with Vaadin. We had actually very, very nice present from our company to all our employees called Sailing Boat. And we wanted to track where it is going. And we bought one of these devices, installed a SIM card there, and then we were able to configure this device with one SMS message to send the GPS coordinates to certain IP address and to a certain port. Then we built a web application using Vaadin, and in that web application, we didn't just serve the 80 port for the web users, but we also served a special port for this device, and we were collecting the data, putting it into the database, and then had the actual web application display the data on a map. And basically the same strategy is used by quite many webcams these days. I'm using one of these Reolink branded ones when I'm looking at my hunting spots. So this way I can see that if it makes sense to go there next day, for example. And these are working in exactly the same way. So they just basically connect to a service provided by this Reolink, and you cannot configure them at all to your own custom device. But then yeah, Reolink provides the SaaS service as is. And these kind of solutions, they usually also have some kind of a REST API where you can then reuse this data into your own solutions. And in principle, Network Printer is working in the same way. It's providing the service in your local area network. But it's network printers these days, they also quite often contain also a web application. So they are running a tiny web server, and you can even upload PDF files straight from your browser to the tiny web server of your printer, and then it prints it. Quite often, actually, when you are delivering a lot of devices, this is one of the best ways to do it. Either using a local network connection or through the internet connection. But that's not always reality that you can create this kind of a packaged and well prepared service. Sometimes you need to build it by yourself from the pieces. And these are pictures from the system that we use in our orienteering competitions. So orienteering happens in forests, and the competitions are like 1.5 hours long, and it takes ages to get people out there, and it's actually really boring, or it used to be really boring to follow these sports because you didn't know anything what was happening in the forest. But thanks to the modern technology these days, we can actually follow the competitions. And online control points, these are like one good system how this can be accomplished. So on the left, you can see the actual control point unit, and that's using the old serial port, and we need to connect that data somehow all the way to the internet. And we are using a custom tailored system where we have a battery, which is the black box here, and then we have a Raspberry Pi. And to that Raspberry Pi, we connect these kind of serial port dongles, and there we connect these actual control point units. And then we have a 4G dongle that is connecting the Raspberry Pi to the internet. And in the Raspberry Pi, we have a really tiny piece of software that is just reading the input from the serial port and sending that over the wire to a network server to a server in internet. And in a simple solution, we could actually use the same server to be as a web service, but in our case, we are actually having the actual result server running in the competition center, and that server is then connecting to this network server, and then we have yet another internet server which is actually serving the public who want to see that what is the current situation in the company. They connect to this other server, and it takes like 1 or 2 seconds for the data to go all the way through the serial port to the Raspberry Pi to the result server, and then all the way back to internet again. But yeah, build it from pieces. This is possible for almost anything. Of course, the parts here, they cost a bit, but these devices, they are recycled on pretty much every competition in Finland. So it doesn't cost that much that it would take to develop like a really like fully productized piece to manage this system. Another kind of variation of network connected devices is to not necessarily use network to connect to your server, but you can also connect through normal wire. So for example, serial port or USB port. In many in-house systems, this is actually pretty handy. So the device doesn't necessarily need to be in the computer that your users are using, but it can be somewhere in the office, and somewhere in the office you can connect that device then to the server, and then the end users who are using browser, they are pretty much anywhere at all. This diagram here is from one system that we implemented at Vaadin or for one of our customer who was doing endurance testing system. So they were testing the VO2 maximum value, which is basically indicates that in how good shape you are, like endurance wise. And in the system, there was basically 4 computers. There was one in the lobby that was using just a browser that connected to the web server, and then we had one in the office that was used for invoicing and also sending out the results. This was actually the only computer that also had an internet connection. All the other computers, they were only having like local area network connection. And then we had the server. And to the server, we actually hooked the exercise bicycles. And that was used to get the watt data through the serial connection to the server. And we also had a printer there because we wanted to print the results automatically. So there might have been like 5 concurrent users or test candidates who were doing this VO2 max test. And we didn't want the test operator to need to print all the results separately. But when the test was over and it was called finished in the operator's admin UI, then the printer just started to print the results, and then people went to the shower and they could take the results as a traditional paper. We were actually using this kind of heart rate monitors as well, but at that point, these were still not using Bluetooth connection, but they were using a custom tailored connection, and we couldn't automate that. So in this system, we actually had a manual interface to fill in the data from the heart rate, and that was probably the biggest part. So the operator needed to type in a lot of numbers from the wrist computers to complete the test. Fifth one is to implement some kind of a special driver application. So I would say that this is the worst thing that you can do, because this involves, or this forces your users to install native application. If you have decided to make a web application, you probably don't want this nasty thing for your users. So, but sometimes it might be the only way to get it work in a proper way. But in this kind of system, you can kind of keep most of the UI in the web application, and then just have like tiny applications, driver applications running in your either in your mobile device or desktop device, and that driver application then connects either to the server or write some files to the local system, and then the web application can pick those files from your local place. There can be sometimes case for a bigger native application, and if you have that kind of system, then having this kind of a driver application makes more sense. I'm actually using one of these kind of systems when I'm hunting. So we have a dog GPS system, and in some places in Finland there are no 4G connection. It's if you go to the very northernmost Finland, there are places where there is pretty much no GSM connection at all. And in these places, we are using this special device that is not using 4G connection to send the dog's location for the mobile phones, but we are using, or they are complementary, using also VHF radio communication. And that's of course so special thing that the smartphones cannot receive that directly. So there is another device that the hunter is carrying, and that is receiving the GPS coordinates through some custom radio protocol, and then that is connected to the smartphone of the hunter through Bluetooth connection, and that is connected to the native app that the hunter is using. And from the native application, that location is then shared to all the hunters that belong to the same group, so everybody can actually follow where the dog is going, even though the dog is somewhere where the network coverage is not enough. And in this kind of system, you can have, for example, like a public viewing API still as a web application, and then have just a specialized version as a native application. But yes, I would say this is the worst thing to do. And for these kind of solutions, there is now these new emerging things coming up that Google Chrome team has been working on. So WebBluetooth, WebSerial, and WebUSB API. So these are now available for some users and some cases, but this is, I would say that this is still kind of an emerging technology. But let's look into those a bit more. So in practice, all these APIs, they open a JavaScript API to the browser, to the navigator object, and one can use that to access the peripheral ports like USB, serial, and Bluetooth. And this way, basically, your web application becomes the device driver. So you don't need any specialized software or any other hacks, or you don't need your device to use special network connection. So they can connect directly to your workstation or mobile handheld device, and web application can access the data from device through this JavaScript API. It might be a bit scary for Java developers because you will be handling a lot of like bit level data in JavaScript. It's doable for some people. I decided to actually do it in a bit different way for my demo. I will see how you can do it with poor Java in a moment. And yeah, they are similar in nature, all of those, just the different protocols. And because of differences in the protocols, the APIs are not exactly the same. One thing about the Bluetooth thing, this newer Bluetooth low energy profile. This is the thing with WebBluetooth. And if you have like really old Bluetooth device, it's probably using this classic Bluetooth or serial port profile. And this is not available even in Chrome by default yet, but you can actually enable that if you open the flags tab in Chrome, and this way you can get this experimental feature enabled. But we will see if that ever becomes enabled by default. So I would highly suggest to prefer these Bluetooth devices or Bluetooth low energy devices instead. Yeah, so basically when connecting to these kind of devices, we need to take some extra attention. We don't want to expose all of our devices to all the internets. So that's why Chrome requires the host application, which is trying to access these hardware ports. It requires that to have a TLS certificate. So basically you need to have HTTPS in the beginning of your address. And also when you are actually requesting a permission from the user to use some of your device, that needs to happen through so-called user-initiated event. So for example, when you arrive to some web page, and if you would be using the onload event and trying to request the device from there, that would be blocked. So it needs to start from the user, that he is clicking some button that yes, I want to use something, and then the browser is showing its own dialog and asking from the user that which of these devices or ports you want to expose for these web applications. So in theory, this is actually pretty secure because, well, at least for developers, because we understand what is happening and we understand what might be happening if we let some service use any of our device. Yeah, maybe it wouldn't be that safe for my wife, who is always clicking yes, yes, yes for all the dialogues to get through them. For that kind of users, it's not safe. But it can be argued that this is perfectly safe. And yeah, in Chrome, these APIs have been available actually for quite many years. First, they were behind feature flags, but nowadays they have been enabled by default. But some browser vendors, which is basically Firefox and Safari, they have been quite hesitant to take this in. They have been arguing that it's not secure, and maybe these things could be used for fingerprinting the user, so privacy concerns. But yeah, I don't really understand the arguments that well. I have actually read a couple of really long discussions in GitHub where people are complaining to Firefox developers that why can't you enable this API? And yeah, that discussion is partly quite absurd in both ways. I don't think this is like less secure, and I think this is actually more secure than forcing people to install native applications, because we have these devices like this and we want to use them. So if we now cannot use the web APIs, then we will be installing some native application from somewhere, and that could actually be even worse. So for example, if you install a native application into Android, that also has this kind of security concerns. And iOS as well. They ask that quite often you see that native application is, can I use Bluetooth on this device? But that's the difference here. These native applications, they grant access to whole Bluetooth chipset, and in the same way for USB devices, you give all the access, not just for one device or one port, but you give access per device category. And I would claim that this web Bluetooth approach is actually more secure, but yeah, go figure. Yeah, the big question is then that, can you actually use this somewhere? I would say that yes, we actually shipped one solution already 4 years ago for one of our customers who had heard about this WebBluetooth thing, and they were really eager to get these thermal printers to print receipts from their Vaadin application. And this proof of concept actually worked pretty well. So it was very new thing at that point, but it was really nice demo that my colleague built for the customer. I don't know actually if it's currently in use, but I would guess so, because the prototype worked really well, and it was rather robust. Also, I have been playing around with this Bluetooth belt, and I have been connecting to one thermometer as well from my example applications, and I have never had actual issues with the actual port communication. It hasn't been the issue, but yeah, if you look at the Mozilla documentation, it considers this experimental, surprise, but yeah. If you can control the browsers, if you are using this in a corporate environment and can force your end users to have only Chrome or Edge or some other Chromium-based browser, then I would say go for it. And if you have a really nice product, like a hardware product, I'm pretty sure that consumers in general, they are either already using Chrome-based browser, or they can use that browser for that specific thing. I don't use Chrome as my default browser. I'm a bit weird web developer in that sense. I think that it's very good for the web community that we have a variety of different browser engines like Firefox and Safari as well. But I'm just fine using Chrome for some special things, like when I want to analyze my arrhythmias. Yeah, let's look at actually the example application that I have built, and then we can look into some questions if you have some. Let's go to IntelliJ first. I have the application, which is this is Spring Boot-based application that is using Vaadin as a UI. I will start it up. So now I'm starting up in the local environment, and at the same time, I think I will install this heart rate belt for myself. So now I'm wearing the belt, and now I need to switch from Safari to Chrome because Safari didn't support that, and I should have the application running at localhost 8080. And now we have the Vaadin application up and running here. And as I told you before, you need to have the user-initiated event, and so that's why I didn't show the dialog in the first load. But now I have the button to connect to the belt, and now you can see this hardware dialog, and now it's scanning the devices, and it found one thing there. There should be actually a lot of other Bluetooth devices connected to this computer as well, because but I used a filter here in the application. So I was requesting only the devices that advertise themselves as a device that serve or somehow provide the heart rate service. And this is one of those device types. There is an older version from Polar. There is another Finnish high-tech company called Suunta providing these things, and I think also Garmin heart rate belt. They are all sharing the same data format for the basic heart rate. And if I click pair there, now I should start receiving some data. And because there is a lot of data coming from this device, because we are getting also the millivolt samples, I'm also getting this ECG thing here. And yeah, basically the lower part of the UI here, this is what you can see with all heart rate belts, and the upper part only with this Polar H10. And yeah, we are showing the current heart rate. Then we are showing some heart rate variability related values, which are basically coming from the RR data. So RR data in heartbeat analysis is Oh, actually, now you can see there is some red one as well. There was an extra beat that I got. It was actually visible in the ECG as well. Yeah, so the RR data is the time between the beats, and it's basically from the peak to peak time. And the variability between these things, that means that there is not that much stress. So if you have done a very hard endurance training, for example, or if you have been drinking a lot of alcohol, or you haven't been sleeping much, then usually these RR intervals, they are almost stable. But when you are kind of relaxed, then there is more variability in your heart rate, and that tells us something. It might, for example, tell for endurance athletes that when it's a good time to do the next workout, and so on. And yeah, let's see how this was actually built. So let's go to the code side. So the Spring Boot application, this is not doing anything interesting. The interesting part is here in this main view class. And this is basically like one class view, because it's just a simple read-only application, so we don't have that much logic going backwards to the belt in this case. So I put everything in one class only. The actual WebBluetooth integration is happening here in a JavaScript file that we inject to this view. Let's look into that first. So this is doing the integration in JavaScript. So we are defining a helper function here that will do all the heavy lifting for us. We are providing a couple of handlers here, and we will be providing these from the actual Abonniere application to get the data for the Abonniere UI code later on. But let's look at this part now, because this is kind of the core integration part. So this is the same API that you already saw in the slides. So we are accessing a Bluetooth object in the navigator, and in there we are calling a method called request device and giving it some filters. Filters are mandatory here, so I guess that's kind of a one privacy thing as well, that you need to provide at least something so that you cannot just look for all the devices that there is and then do something with those. And when the end user has actually selected the device, as I did just a while ago in the application, then we get a reference to the device, and from the device we are connecting to this GUT object here. So this is the Bluetooth low energy thing, and it's a bit kind of a REST style API to get data and push some data for the devices. And we are connecting to the device's server. We are getting the heart rate service, and then we are interested about the heart rate measurement, and we then add an event listener for that heart rate measurement, and we hook our handler there. And now we have the heart rate coming from the device to the actual UI code of the application. And then we are doing the same thing for ECG. So this is the polar H10 specific feature. So this PMD service is actually stolen from the Polar's own Android toolkit, which I actually planned to use initially directly, because that was built with Java and Kotlin. But actually it had so many references to some Android specific libraries that I finally just picked up some of the constants and some of the methods from there and used my own integration, completely own integration. And here we are doing basically the same thing. One difference is here that we are actually pushing out some data also for the device. So we need to configure it with custom bytes. And I don't actually know what these are, but these are also stolen from the Polar's official and Android SDK. So basically we are saying that send us also the millivolt values with the highest possible sample rate. And after this command, we can register similar handler for the PMD data here. And then we are getting all that low-level bytes from the belt. All right, let's go back to the main view. So here, when we have the connect button here, when we click it, we are executing this method. And here we are basically removing all the initial components, so the button and the text that we had there, and we built the reporting UI. So we put all the components in place. We have the data table, couple of charts, and so on. And then we define these handlers. So here we are just basically taking in the new buffer, which is the raw bytes coming from the device. And this is kind of a workaround for small limitation in Vaadin, because in Vaadin client-server communication, there is no built-in way to transfer raw byte array from the JavaScript to the server-side Java. So we need to put that into JSON message of some sort, or actually to a plain string here. And we use base 64 encoding, and we move up the data over to a method which is on the Java side, and with this annotation that is exposed. So that's why we can call it from the JavaScript that I just showed you. Then we decode it back to the byte array, and after that, everything is pretty easy. So this is the tooling that I built, and everything here is basically just plain Java. Now it's easy for a Java developer to get the byte array, get all the byte flags, read the values there. Well, it would be difficult unless you wouldn't know what the data consists, but for that, the Android toolkit was actually really helpful. So that's why it was pretty easy to write this method. This method is supporting also non-polar devices, so they might be using 8 bits instead of 16 bits for the heart rate, and it's also getting the RR intervals if they are present, like in most modern things they are. As we are running out of time so much, I will actually skip explaining this part that is taking in the ECG samples, but it's basically doing the same thing. So we get the data from the byte array, and then we are parsing that into some Java structure. So I'm using new records here for the data, and then we are just updating the UI components. So the time, it is this label here. So we are updating that each time we get new update from the belt, and then heart rate, it's this one, and we update that as well. And in the same way, we are just updating these components that we have here, displaying the charts and doing the analysis. The rest is just Java. You can check the example application from the internet and get inspired about that. All right. Yeah, this is the address to the example application. I can probably share the slides somehow after the presentation, so that you can look into the code if you want to build some WebBluetooth application by yourself. I think you should, even if you were not using Vaadin, I think you should be inspired by the mechanism of moving the raw bytes from the device to the Java server side, and then doing all the heavy lifting in the language of your choice, Java. Thank you. Questions. how do I see the questions? Chat. All right, only thanks arriving to the chat box. So, there is actually one question. Do you use a library for HRV calculation? No, I didn't use a library, but I actually looked into some scientific papers, and I took the approach that they were using for heart rate variability, and I implemented that as a simple Java method. So you can actually check the source code, and there should be one method. And in the example, I was actually using just, I think it was just like last 10 points. But if you're using it for something real, I think you should be using a bigger amount of samples to get more stable results. And yeah, the GitHub link, yeah, but let's put that visible there. Do you think it's possible to connect and use script to control Lego car? Script. I have no idea what that is, but if it's using Bluetooth low energy profile, then I'm sure that it can be used. It might be difficult unless you can find some kind of a reference implementation to kind of do the right things in the very, very low level things that there is involved in this kind of device integration usually. But if you have a reference library, for example, then yes, it's very easy. And if you're a very skilled developer, then you can probably actually sneak into the communication between the Bluetooth devices and see what's happening with the official driver, and then reuse that data and kind of reverse engineer the communication logic from that communication. Do you think that these APIs will suffer the same fate as Java applets, security reasons and lower level access? I don't think so. Google is very committed to these APIs. If you haven't figured out, they are actually providing 2 operating systems. They are providing Android, but also Chrome OS, which is actually surprisingly popular these days. And these are very essential APIs, especially for Chrome OS. And they are not going to let this loose very easily. And so far, at least, I haven't heard any security issues concerning these APIs directly. So I would say that these are here to stay, and I would expect that also other browser vendors at some point they will give up as well, and they will implement these APIs. But yeah, this kind of standardization that takes a lot of time. It has taken years for Apple to provide support for the standard push mechanism, but it's finally now available in the latest iOS versions. It might be that there might be some tiny changes that come to these APIs when also Mozilla and Apple engineers are involved, and they might propose some extra security enhancement to these APIs. But I think they are here to stay in some form at least. All right, thank you, and I hope you can see the example by yourself. Check it out, try it out. If you have any of these belts, go and try it out yourself and see what is possible today with devices and web apps.